All right, this is example-ish, one-ish, sort of, prior to example 1. This is the prologue to example 1 of lesson 2.1, which is variables and expressions. Now we're going to start getting into the real nitty-gritty of basic algebra. And I say basic because it is so basic. You've been doing it since like the first grade and you haven't even realized it, okay? So, the reason I'm doing a prologue to example 1 is because I need to tell you that the way that you've been writing math problems since kindergarten, first grade, is not exactly how we're going to be writing them from here on out. You're going to need to be able to recognize some sort of strange-ish methods of writing multiplication and division, specifically multiplication and division. Addition and subtraction, they're not going to change, but multiplication and division are. And for the first time ever, I'm going to start with division because it's actually simpler than multiplication when it comes to this sort of thing. So let's look at division. I write a division problem as such as 4 divided by 2. This division symbol here, it's not going anywhere. This division symbol is not going anywhere. It's going to stay exactly how it is. We can still use that, not an issue. However, we are going to use another way to show division, and that is one we've been using a couple of times, the fraction bar. 4 divided by 2 can also be written as 4 over 2. These two things are equal. Both equal 2. So whenever I see a fraction like this, I need to twist my brain a little bit so I don't think of it as a fraction, and I think of it more as a division problem. You can still think of it as a fraction, of course, as long as right alongside it, you also think of it as a division problem. All right? That's division. We can still use this, but now we're going to add this, and we need to recognize that as division. Okay. So, what about multiplication? Now, here's the tricky bit, because we're introducing variables. A variable, the definition of a variable, according to this, is a letter that stands for a number. And this isn't meaning that A always means 1, B always means 2, C always means 3, etc. That's not what it means. A letter, a variable, can mean anything that I need it to mean, or in most cases, whatever makes the sentence true. So, when I say you've been doing algebra since first grade, this is what I mean. 6 plus what equals 10? Okay, we know this, obviously. This equals 4. 4 goes there. However, I could rewrite this as 6 plus x equals 10. And now I'm doing algebra. So you've been doing algebra since like the first or second grade and haven't even really realized it. This is the same thing. Only instead of a blank, we're putting a variable in. In this case, x equals 4. But if I did 3 times, oh, now here's an awkward thing. 3xx, that's why we're switching it. Because if I go 3 times x, it looks like 3xx, which is a clothing size, not a math problem. Although 3xx isn't a clothing size either. So we don't use x anymore. What do we use, you ask? Good question. Thanks for asking. What we use instead are 3 things. 1, instead of the x, we use a dot. So you might have seen this in my class on the quizzes we did the other day for review. 6 times, if the program will let me, of course, x. Or I might use this, 6x. This means to multiply. If I've got a letter squished up to a number here, that means multiply. The other method, the last method we're going to talk about, is this one, 6x. Like that. Put it in parentheses, squish a number up to it, that means multiply. Why would I do this when I can just do this? Why would I do this when I can just do this? Well, what if I'm doing, as I was going to use my example earlier, 6 times 4? Well, this would be 6 times 4. This would be, oh, I can't do that because that's just 64. These two things, not the same. So that's why we have the parentheses here. That's not the only reason, but it's a good one. 6 times 4. So when I see a number squished up against parentheses with another number in it, this doesn't mean, oh, I need to do the 4 first, like in order of operations. because there's nothing to do to that 4. It's just 4. This means to multiply. So now I've got the dot means multiply. When I have a letter and a number squished up against each other, it means to multiply. And when I have something in parentheses squished up against a number, that means to multiply. These are all different methods of multiplication. I know this video is kind of long. Please, and thank you. I'm very grateful for you for watching to the very end. I feel like a YouTuber right now, but I'm not. Thank you for watching to the very end, because this is really important. Otherwise, you're going to see these and you're going to get confused. I also want to take this moment to remind you all that 6 to the power of 2 does not equal 6 times 2. It equals 6 times 6. And if I did x to the power of 2, it would equal x times, I just did it again. See? Look at me. Look at me. I'm so used to it, I'm doing it as well. X times x. The dot means multiply. We are no longer using the x. When we're doing things on the computer, this is going to be our preferred method, because I can find the dot, and I'll see if I can figure out how to find the dot on a Chromebook, but using the parentheses for multiplication is going to be our preferred method from here on out. Okay? The dot, if you're writing things down on paper, is probably the easiest. Parentheses is easiest on the computer. Thank you for watching this whole thing.